Yeah, so last 3 days, in last week, we discussed about DevOps introduction. What is DevOps? What is automation? Why DevOps? Why the project teams are looking for automation tools, DevOps tools. So why the automation is very popular. So why the companies are looking for DevOps engineers, right? So what are the job opportunities we discussed, right? Yeah, and also we discussed about AWS cloud introduction, right? What is cloud? Why cloud? Why the project teams are looking for cloud infrastructure? So what are the advantages of cloud, right? Why the project teams are migrating their infrastructure to cloud? And question and answers, right? So three demos completed, right? From today onwards, yeah, we are going to start basics of networks and servers, right? Yeah, so these basics are very very important. So when we join into the project, right? So this while before working on cloud, first we need to understand this basics, right? So what is server, what is network, what is switch, what is router, what is load balancer, right? What is data center? These are all very important. Yeah, so everyone, can you mute yourself? So if you have any questions, you just hold down. You can note down your questions. I give you time for asking questions end of the session. Okay, so if you have any questions, you just note down that questions. You can take down that questions. I give you time for asking questions. You can ask by the time. Okay. Yeah. So middle of the session, if you ask any questions, recording will be disturbed, right? That is why I give you time for asking questions. Okay. Fine. Yeah. So today's agenda here is what is server, types of servers, server client model and best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, IP address, subnet mask, gateway, router, firewall, failover, and load balancer. So these are all very important, right? So this terminology, this basic concepts are very important. So first we need to understand this before going to cloud, right? So once you understand this, it is very easier to understand cloud platform, right? Yeah, once we complete this basics, we'll jump into cloud, AWS. Fine. So before going to cloud, we need to understand all these terminologies, all these terms. Fine. Yeah. What is server? What is server? Anyone? What is server? Anyone having idea about servers? Server is a computer, right? Server is a computer. Server is having high computing power, high memory, high CPU, high RAM, right? To serve the request to the other computers, right? So normally in real-time projects, so always we connect with the servers. We don't use on, we don't work on laptops, right? Yeah, normally developers, they don't develop the code on their laptops, right? They connect the servers through laptop. In the server only they start the development activity, right? So server is having high computing power, right? So it serves the request, it serves the request, it serves the, it shares the data, right? We can access the data. Fine. Yeah, so definition here is a server is a computer that serves information to other computers called clients. What is client? Client is a desktop or laptop. So we can connect clients, we can connect servers through clients, right? So we can connect to a server through either a local area network or a wide area network such as the internet. So local area network, LAN connectivity through LAN, some cable network, we can connect our servers, or else we are using currently Wi-Fi. Most of the companies, they are using Wi-Fi only, right? So when you move to cafeteria in office, or when you move to breakout area, we can carry the laptop, right? Through Wi-Fi we can connect our servers. Fine. Yeah, server is a computer that serves information to other computers called clients. Client is nothing but either desktop or laptop, right? Next one, types of servers. What are the types available? So these are the, yeah, three types of servers are available. So currently, in real-time projects, Yeah, we are using very few servers in local data center. We are using very few servers because most of the servers we migrated to cloud. Most of the infrastructure we migrated to cloud. So in our project, yeah, 5 years back we used to use 1,000 servers in our data center, local server room, right? Currently we are using so nearly 30 servers only because of so cloud infrastructure, right? We migrated all the applications to cloud data centers, right? So what is the use of cloud? What is cloud? We discussed already, right? What is the use of cloud? Anyone? What is the use of cloud in industry level? What is the use of cloud? We discussed already. Right. Right.
Minimize the time
Cost
and
saving,
cost.
cost saving, and time saving, right? So when you
Cost
want
and
to
time.
build, yeah, when you want to build any physical server in your local data center, that takes some time. So we need to place the order with vendor. We need to get the server from vendor. We need to move to data center. We need to configure into the racks, right? We need to connect power and network. We need to install operating system, applications, patches, everything, right? That takes some time. That is why, so most of the project teams they are using cloud servers only. Because so when you want to create any server, cloud environment server in cloud data center, that will be available within 1 minute, right? So for example, I require 100 servers today. I can create within 1 minute with all packages, all configurations, all patches, all applications, right? So cloud infrastructure is a on-demand infrastructure. What is on-demand? Instantly, right? Yeah, so these are the physical servers. I'm talking about physical servers, not cloud servers. So if you understand this terminology, you can easily understand cloud terminology, right? Yeah, so in physical data centers we have three types of servers available. So blade servers, rack servers, and towered servers. What is blade server? So blade server is a modular server that allows multiple servers to be hosted in a smaller area. So this is one of the container. Instead of the container, we insert this small servers. These are very thin servers, right? So inside of the server, only CPU and RAM. Hard drive will not be available. But without hard drive, without storage, how can we store the data? We use external storage. We use external storage, right? Yeah, so a blade server is a modular server that allows multiple servers to be hosted in a smaller area. So these servers are physically thin and typically only have CPU, memory, and integrated network controllers, and sometimes storage drives also inbuilt. Some devices we use the storage drives also. Most of the blade servers we use external storage, right? So blade servers often seen in large data centers. Enterprise level, we use the blade servers. So these are very thin but very high performance servers. In Google, UHG, Microsoft, we use this blade servers. Okay, so enterprise level. Second one is rack servers. What is a rack server? So a rack server is a server mounted inside of a rack. See here. So this is one of the rack, one of the big container. Instead of this rack, we can set servers like this. So backend we can connect power, network, right? Yeah. So rack servers are typically general purpose servers that support a broad range of application on computing. So most of the data centers they are using rack servers. Enterprise level we are using blade servers, but most of the data centers we are using rack servers. Okay. Yeah. Next one, towered servers. What is tower server? A tower server is a computer that is built an upright cabinet at that's standalone and that is designed to function as a server. So this is the bit older server. Tower server is bit older server. Yeah, so this tower is having one upright cabinet. So instead of this tower, we connect one monitor, one CPU, one keyboard, and one mouse. So one container, one server only. That is tower server. So yeah, before rack servers, we used to use this tower servers. Okay, so these are the three types of servers are available. So most of the data centers they are using blade servers and rack servers only. These two servers. Most of the cloud data centers, physical data centers, They're using blade and rack servers. Fine. Now, so client server model. Client server model. So this is our server. These are the client. So we can use any desktops or laptops to connect our physical servers, right? Yeah. So through network, through LAN connectivity, or through WAN connectivity, or through Wi-Fi, we can connect our servers, right? So when you send request to the server, it will give response immediately, right? Yeah. So servers are having very high computing power. We discussed, right? So when you try to access any of files, when you try to access server resources, that will give response immediately. Fine. This is another model, client server model. Through internet, we can connect our servers through laptop or desktop. Even you can use tab also to connect your servers, right? Yeah. Now let's try to understand server architecture, right? What is server architecture? The server architecture is the foundation layout or model of server. So based on which a server is created and are deployed, it defines how a server is designed. Okay, let's try to understand. Yeah, server architecture, you can say first phase of implementation. First phase of implementation. So this we can say initial phase of implementation. First phase or initial phase. First phase or initial phase. So in 90s and early 2000, in 1990s and early 2000, how the server architecture, 90s, 1990s and early 2000, how the server architecture, how the project teams used to use the servers, how they used to design the servers, right? So we'll try to understand. For example, I have four applications are there. I have four applications like Java, .NET, and also Python, and also I have another COBOL. So by the time, very old language, right? 1990s and early 2000, very old language we used to use, right? For example, I have four applications are there. So on this, by using these four applications, I want to start the development activity in my project. For example, so I'm talking about 1990s and early 2000. How they used to configure the servers. We'll try to understand. Okay. Yeah. So by the time in 90s, in 1990s and early 2000, they used to configure servers for one application, one server. One application, one server. Right? Yeah. So here we have four applications. They used to take four servers here. For each application, they used to take one server. Like this. Okay. Yeah. So here by the time highest capacity of the storage in 1990s and early 2000, highest capacity of the storage is 1 GB only by the time, right? These are all 1 GB servers, 1 GB storage servers, right? Yeah. For example, here I deployed Java on the server. I deployed Java. Java will take, yeah, for example, 300 MB, right? Yeah. So remaining space will be wasted, right? For each application, we are using one server. Yeah, so remaining 700 MB will be wasted. Next one, so .NET application, it may occupy 400 MB. So remaining space will be 600 MB space will be wasted. Right? Yeah, and also Python. So Python will occupy, for example, 450 MB. Yeah, so remaining 550 MB will be wasted, right? So and also COBOL or Pascal by the time we used to use, right? COBOL. So it may occupy some 350 MB, MB. Remaining space will be 650 MB will be wasted here, right? Yeah. So earlier in 1990s and early 2000, we used to use the servers like this. So each application we used to configure one server, right? So here what is happening here? So server costing by the time 1990s and early 2000s, server hardware costing it was very higher. So by the time, so yeah, desktop costing, laptop costing, and server costing, very higher costing, right? Yeah. So here what is happening? So utilization of the server is less, costing more, right? So that is why project teams, project clients, they used to spend more billing for the hardware, right? So less, yeah, less profits and more costing. That is why this is a failed concept. This is a failed concept. This is failed. This concept is failed, right? So slowly, after 2000, they move to another stage of implementation, second stage of implementation, right? So now in second phase of implementation, so actually client always look for the cost saving, right? Client always look for the cost saving, right? So here in first phase of implementation, costing is higher and yeah, profits are very less, right? So that is why they move to another phase, second phase of implementation. So by the time, so when they move to second phase of implementation, what happened here? They used to take highest configuration of the server, one server, right? And they used to deploy all the packages in same server, all the tools, all the all the project packages, right? Like here, Java on single server, Java, .NET, and Python, right? And also COBOL. So all the packages they used to install on same server, one server, and they used to connect to one server only. So they used to take highest capacity of the server, one server, single server. This is the second phase of implementation. So here what will happen? Java developers they connect Java server, right? So .NET developers they connect .NET server. Python developer they connect the Python server. COBOL they connect COBOL servers, right? So everyone they can connect their respective applications, right? So yeah, everyone they can connect to the same server, but they can log in into Java, .NET, Python respective application, right? Yeah, here what will happen? So four members are connecting same server. They're accessing their respective applications. So here there may be chances to access, for example, Java developer, there may be chances to access .NET application. .NET developer, there may be chances to access Python application. Python developer, there may be chances to access COBOL application. So there may be chances to access other applications also. For example, four people are staying in one flat, 2 BHK flat. Two people are staying in one bedroom, two people are staying in second bedroom. The four people commonly access kitchen and dining, right? Same way, so when we log in into the server, there may be chances to access other applications also. But security layers will be there. Security will be there. There may be chances to access other applications also, right? That is one drawback. And also, if the server is crash, what will happen? All the applications will be gone, right? So that is why this is also failed concept. Second phase of implementation also failed. Okay. Yeah. Slowly, in third phase of implementation, what happened here? So virtual servers came into the market. So virtual servers, virtual environment. So here, yeah, we have different virtual servers are there currently we are using, right? Yeah. So in virtual environment, what will happen? We take one high capacity physical server. This is a, we can say this is a base OS, base operating system. Okay. So this is a base server. This we can take high capacity server. One server we can take high capacity server. So on top of that, we install one package, which is we can say VMware or hypervisor or Citrix. These are all virtual layers, virtual softwares. VMware or hypervisor, Hyper-V or Citrix. So these are all virtual softwares. This is simple package. This is software. So once we install this software on base server, one server, physical server, what will happen? So this software will allow you to create virtual servers. Understanding, right, everyone? Yeah. So if you want to create virtual server, what is virtual server? It is a, it is not physical. It is a imaginary server, right? It will work. Yeah, it will work as a server, but it is not physical server. Fine. Yeah. So once we install any, yeah, this VMware or hypervisor or Citrix, what will happen? This will allow you to create physical virtual servers on top of the physical server, right? Yeah. Now I can create virtual servers on this physical server. Yeah. So here, yeah, these are all virtual servers. So in virtual servers, these virtual servers, we can create different operating environments, different operating systems. Like here, I can install Windows 2016. Here I can install RHCL and Hat Enterprise Linux. Here I can install Ubuntu Linux operating system. This is, yeah, CentOS. Here I can install Windows 2019. So like this, yeah, these are all virtual machines. These are all virtual servers, right? Whatever operating system you required as per your project requirement, you can install, right? So these servers will work as a physical. It's like physical server, but we don't find any hardware here. But these virtual servers take the resource from where? So for example, sorry, can you go? Base servers, right?
Yes.
Yeah. This virtual server take the resource from base server only from here, right? So base server is having high computing power, high capacity of the RAM normally 48 GB we use in servers, and CPU we can use 32 core, 32 core, and hard drive storage we use 10 TB, like this highest capacity. So this RAM, CPU, hard drive will be shared to the virtual servers, right? So these servers will work individual, right? But resource will be taken from the base OS, base server. Fine. Yeah. So currently we are using virtual servers. Okay. Yeah. So in virtual servers also having some drawbacks here. Virtual servers also having some drawbacks. What are those? So when you want to deploy operating system on a virtual server, right? We required one ISO image. What is ISO image? ISO full form is, yeah, International Standardization Organization, right? It is a master copy. So ISO image is a master copy, one software to install operating system. For example, in your laptop, if you want to install Windows, what we will do? How can we install Windows? We take one image, right, into pen drive. The pen drive we can configure as a bootable drive. So by using that, we can install operating system on the laptop or desktop. Same way, for installing the operating system on server also, we use the image, which is the master copy. Even cloud servers also we use the images. Okay. Yeah. So by using this ISO image, we can install operating system on the virtual server or physical server. Fine. So this ISO image size would be minimum 6 GB to 18 GB. So this ISO image size 6 GB to 18 GB. So for example, we have 25 servers here, 5 into 5, right? Yeah. So each server is having on an average 10 GB storage, 10 GB for only operating system, right? So here we have 10 into 25. How much size it will take? 250 GB for only operating system. So on top of that, again, we need to install applications like Java, Python, whatever applications we require. So patches we need to install, drivers we need to install, right? Plugins we need to install. So that will take more space, more storage. That is one drawback. So when we use virtual servers or physical servers, so yeah, servers will utilize more storage. Storage costing is very higher, right? This is one of the drawback. And also when you restart, when you reboot or restart, both are same. When you restart your server, it takes minimum 4 minutes to 8 minutes. When you restart server, it check the memory and integrated controllers and updates, patches, slowly it will restart, right? So normal laptops and desktops you can reboot immediately, but server high computing power, right, will take 4 minutes to 8 minutes. So normally in real-time project, currently for example, we are using digital applications, Flipkart, Amazon shopping site, right? So when you restart server, it is taking 4 to 8 minutes, right? So if the server is taking 4 to 8 minutes, for example, Flipkart is running, Flipkart server is restarted. If the Flipkart server is taking 8 minutes time to restart, what will happen? Business will be impacted, right? That is why this is also one of the drawback, right? And also deployment time and downtime is very higher. Deployment time and downtime. What is downtime, anyone? Maintenance time,
Maintenance
right?
time.
Right.
Yeah, server
So,
maintenance time.
for example, when we in real-time projects, we install monthly patches. That is one of the activity, right? Patch. What is patch? Anyone? Update, right? In our mobile, Android mobile, we get updates, right? Once we update that, it will automatically restart, right? Same way, server level also we get some updates, right? So that is one of the activity every month we need to perform, right? So once we install patches, server should be restarted, Windows Server or Linux server, right? Yeah. So that is a downtime. We can say downtime, maintenance time. So deployment time. So when we deploy any applications, that will take some time here, right? So deployment time, downtime is higher in physical or virtual servers. These are all drawbacks. Still, we are using virtual servers in our projects, but these are the drawbacks, right? So that is why currently the project teams are looking for Docker containers, advanced infrastructure, right? So virtual servers also having some drawbacks. That is why currently we are using Docker containers. That is very advanced one. Okay. Now let's try to understand fourth phase of implementation. So here we discuss about Docker architecture. Docker. So this is very, very important. So currently most of the project teams are migrating to Docker. So currently we are using digital applications like Flipkart, Amazon shopping site, so Meesho, Myntra, Dunjo, Zepto. These are all digital sites, digital applications. So currently we are using those applications because of Docker. So when we book any product, that will be delivered within 5 minutes, 10 minutes also, right? So because of Docker containers. Okay. Yeah. So in fourth phase of implementation, for example, this is Docker server. This is Docker server. It can be cloud server. So it can be AWS server or Azure server or Google Cloud server, right? Yeah. So here on top of this, first we need to take one server. We need to configure server. So on top of this, we need to deploy one package, which is, you can say, Docker image. Docker image. So on top of that, what we will do, we can create containers. Yeah, these are all containers. So in these containers, we can deploy different operating environments. So here I can deploy Ubuntu, RHEL, CentOS, Windows. So here I can deploy Windows 2000. So whatever is required. So different operating environments you can deploy on this containers. So what is container basically? What is container? Anyone having idea? Right. Okay.
They're
So
having a storage.
right. So in general, what is container? In general,
It's a
yeah.
uh,
In
kind
general,
of a room.
okay.
So
Box.
application contains, container contains its only application without any memory and CPU.
Right.
General to
Yeah.
store something.
Fine. So container is a box, simple box. For example, it is a box, right? Yeah. So that box, we can, yeah, in that box, we can store any data, any data. We can move anywhere, we can use anywhere, right? So it is a lightweight environment, lightweight. So these containers are lightweight, right? So lightweight means what will happen here? So when we run the container, only in this container, lib and bin files will be installed. Library and binary files only. When we run the container, only library binary files will be installed on this, right? Yeah. So here we are talking, we discussed about images, right? Images. So when we create any server, it takes 6 GB to 18 GB. Sorry, this image size. The storage size minimum it will occupy 10 GB, for example. Okay. But when we run the container, yeah, can you mute everyone? Some background noise is coming here. Yeah. So when we use the containers, what will happen? Only lib and bin files will be installed on this. Okay. Yeah. So this size would be, container size would be 200 MB only. 200 MB, not 6 GB, not 10 GB, not like that. So containers are very lightweight, right? So it will occupy 200 MB only. So along with all applications, everything will occupy maximum 650 MB only, maximum, right? Yeah, and also when we restart container, it takes 15 seconds only. 15 seconds. When you restart container, it will not take 4 minutes, it will not take 8 minutes. So when you restart container, yeah, whoever working on the container, they don't know the container is restarted or not. It is very faster, right? And also deployment and downtime is very less. Deployment time and the downtime is less. So when you deploy any applications on container, that will not take much time to deploy. When you down your container, when you restart your container, it takes 15 seconds only, right? So here always, yeah, as we discussed, client always look for the costing and cost saving and time saving, right? So containers, when you deploy any application quickly, very faster, right? So when you down, so normally we don't require any downtime for containers. We don't require any downtime, right? Yeah, we don't need to get any approvals from management, client to down the containers. So because when you want to restart, you can restart immediately. Okay, application will not be impacted here. Fine. So these are all advantages. That is why most of the project teams, they are migrating to Docker containers currently. Their infrastructure, they are migrating to Docker containers, right? So already 30 to 40% project teams already migrated. So other projects also, they are migrating to Docker containers to reduce the time, to reduce the costing, right? And moreover, this Docker licensing cost also very less. Docker licensing cost. So Docker launched in 2013. Okay. Yeah. So before Docker also, we used to use some containers. Before Docker also, we used to use some containers. Okay. So this container concept is not new concept. Container concept is very old concept. So before Docker also, we used to use the containers like LXC, container name LXC, Jones, and LMCI-FI. So these are all the containers. Earlier we used to use before Docker, but these containers are not very popular. Okay, so LXC is a Linux container. Jones, it's a SolarEdge container. LMCI-FI, it is a Google Cloud, Google containers. So these containers are not popular, but Docker launch, Docker is very, yeah, year on year it is growing, right? So currently Docker is very popular. Why the Docker is popular? Because of, yeah, Docker is a platform independent. Platform independent. What is platform independent?
On any operating system we
Depend
can
on
run.
any kind of platform or operating system.
These are all platform dependent. LXC, Jones, LMCIFI. These are all platform dependent. This is platform independent.
Server we can operating system. Any operating system we can install.
Right. Yeah. Platform dependent, platform independent. So what does it mean? So Docker, irrespective of operating system, right? We can run on any platform. Docker can run on any platform. For example, shell scripts are there. Shell scripts. Shell scripts run on only Linux, but Python scripts we can run on any operating system, right? So platform independent means, so it can run on any platform like Windows, Linux, Solaris, even Mac OS also. So it is a platform independent environment, right? So it can run on any platform. That is why Docker is very popular now. Fine. So Docker is having very important advanced features, right? So we have another one also currently we are using, which is Kubernetes. Kubernetes is advanced to Docker. Docker is very advanced one. Kubernetes is having very advanced features. Currently, Docker and Kubernetes, these are very hot in the market, right? If you are good in Docker and Kubernetes, you can easily crack your entry, right? So in your resume, you need to showcase Docker and Kubernetes also, along with Git Jenkins, so that you can easily crack your entry. So learning Docker and Kubernetes is very easier, but you need to spend some time. You need to focus on that, right? Any questions here, anyone? Anyone having any
What is
question?
the use of this Docker image?
Docker image, right? So this is the layer. This is the virtual layer. This will allow you to create the containers. Same way here also, VMware hypervisor. This is the layer. This is the software. Even Docker image also software, right?
Okay, thank you.
Hello.
Yeah, go ahead.
Okay, my understanding is that these ISO file size is 6 to 18 GB, and then Docker it will convert to 200 to 650 MD in binary and libraries. Then at the time of the deployment, it will extract the files and it will do this application activity or whatever it may be. Am I correct
No,
or is it?
not like
Mm,
that.
mhm.
Not like that. So normally, operating environment itself, it is a thin layer, like library
Okay.
binary files only. So normally, when you
Okay.
want to install any operating system on virtual servers, it will
Okay.
install all the packages, all the drivers, all the graphics,
Okay.
brush,
Okay.
right? Everything, right?
Okay.
But here
Okay.
it is a thin layer. This
Okay.
Docker containers not required any graphics, not required
Okay.
any paintbrush, not required media
Okay.
player,
Okay.
right?
Okay.
Yeah. So to
Docker
deploy the
Huh?
yeah to
Docker
deploy the
can be
application,
crashed, sir.
Docker can be
Docker servers can be crashed, sir. Is there any chance?
backend clusters will be there. Clusters. Backend we configure clusters. What is cluster? Anyone? Cluster. What is cluster?
A, a group of
All
servers
servers,
working as a unit.
Group,
the high
any
availability
group.
servers.
Cluster is nothing but group of servers, right? So they work as a group, right? If one service crash, nothing will be happen. Fine. For example, in our team, 10 members are there, right? In 10 members, 5 members went on leave. So each member getting 30 requests per day, 10 members. So if the 5 members are went on leave, what will happen? That load will be shared to other members, right? In that 5 members, 2 members gone again on sick. Other 3 members will take care, right? So like that servers. So we configure as a group so that one server is crash, nothing will be happen. Application will not be down anywhere. Okay. So what is the advantage of cluster here? Anyone? Advantage of cluster. This is an interview question. What is cluster? Advantage of cluster. Anyone? Advantage of cluster.
Server will never be down.
High availability.
High availability. Yes. Yeah. Load balancing and
Yes. Yeah.
fault tolerance. We can say load balancing and fault tolerant. Okay. I'll explain that. So if I give now, you'll be confused. Okay. So these terms are very important. While working on load balancing, I explain that. I give you no deep dive. Okay. So cluster is nothing but a group of servers. What are the advantages of cluster is nothing but it's a load balancing and fault tolerant. Okay. Yeah. Any more questions? Anyone up to here?
Excuse me, sir. Sir, for the application restart, downtime is the 15 seconds, as you said, sir. But is it like someone is making some transaction during that time? Is it impact that user, sir?
No, no, no. It will not be impacted. So yeah. So that is also important point. Yeah. So normally containers also having some internally they have uh, some groups. I explained that while working on containers. So I explained that. So normally we don't restart containers, but restart not required here. So normally when you want to perform any maintenance activity, so getting the downtime is very difficult. Very, yeah, client will not accept, management will not accept, right? Yeah. So because if you down any server, so if the server is not started properly, not restarted properly, application will be down, right? So that is why, so getting the downtime is very difficult in real-time projects. So containers, normally we don't restart anywhere. Okay, there is a process explained. So this is just a high-level architecture. While working on Docker, we'll go deep dive. So it's very core tool, very advanced tool. Fine. Yeah.
So, container also like a server, right?
Containers, we should not call it as server. It is a container. Advanced to servers, advanced to virtual servers. Okay, fine. Go back to slides. So this server architecture we'll discuss again. This is the architecture. We'll discuss it again. Okay. Now, next one is, what is operating system? What is operating system, anyone? Operating system. Anyone having idea? So currently we are using Windows in our laptop, right? In server side, we are using Linux, right? Yeah. So operating system. Operating system is a
It's the software that manage hardware and software resources.
right. So operating system is a interface. It is an interface. So if you want to connect your system, we require one interface, right? So normally hardware, computer hardware always understand the binary language. Binaries. What is binaries? What are the binaries? 0000011001111, right? So hardware understand only binary language, but a human will not understand binary language, right? So users will not understand binary language. That is why we required one translator, which is nothing but operating system, right? See here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. So hardware, what it will do, will convert from binary language to human readable language and vice versa for effective communication, right? See here. So between hardware and end user, there is a layer which is operating system, right? So this will convert into binary to human readable language and human readable to binary language, vice versa. Next one, types of operating systems. What are the types available? Single user, single tasking operating system. What is this, right? Yeah. So in this type of operating system, yeah, for example, MS-DOS. In this type of operating system, only one user can log into the system and he can perform only one task at a time, right? Which is nothing but single user, single tasking operating system. So, for example, MS-DOS, Microsoft Data Operating System, right? So, in this, only one user can log in. He can perform only one task at a time. Second one is single user multitasking operating system. So one user can log into the system, it can perform multiple tasks at a time, which is nothing but Windows. In Windows, while browsing internet, we can run background audios, right? While working on any activity, we can run some audios, background audios. Multiple activities you can perform at a time as a single user, right? Yeah. Next one, multi-user multitasking operating system. In this type of operating system, multiple users can log into the system. They can perform multiple tasks at a time, which is nothing but Linux, right? So in Linux servers, at a time we can log in, multiple users can log in. While deploying the code, while deploying the application, developers log into the servers, testers log into the servers, DevOps engineers also log into the servers, right? They can perform their own activities, right? So Linux servers allows you to log in, fine. So currently we are using in the backend data centers, server side we are using Linux only. Desktop side we are using Windows. Server side we are using Linux only. So why we are using Linux? We can use Windows also, right? Server side.
Safety and
More secure.
because of security, right?
Scripting.
So Windows and Linux, when you compare Windows and Linux, Linux is more secure, right? So when any threats happened and when any virus happened, directly attack the Windows first. But Linux servers are very safe. So Linux also having some threats, but 5% chances. But Windows having more chances, right? That is why most of the project teams they're using Linux only. And also other advantages. So Linux work well. For example, normally in real-time projects, what will happen? Once we deploy patches on servers, make sure the server should be restarted. Windows servers I'm talking about. But Linux don't require reboot, right? Without reboot also Linux will work. In our project, last 5 years we haven't reboot few servers, like 15 servers we haven't reboot. Last 5 years we haven't restart the servers, Linux servers. Without restart also they are working well. But Windows servers, once you install patches, make sure the server should be restarted. Otherwise server will not work properly. The changes will not be reflected. Linux not like that. Without restart also Linux work well. Okay. And also in case C drive is full, we get some errors in Windows, but Linux will not get any errors. Okay. This type of advantage. These are the advantages of Linux. And licensing, freeware. Linux is freeware. Enterprise level, some charges will be applied, but normally freeware, open source. Okay, that is why most of the data centers they are using Linux for server side, right? So desktops, laptops, you are using Windows operating system, right? So clear, right, everyone? So this networking concepts will start tomorrow. So networking concepts will take 1 hour, right? So today we understood like servers, about servers, right? So what is server? Types of servers, server architecture, and operating system. Fine. These are very important basics. Okay, if you understand these basics, you can easily understand cloud infrastructure. Fine. Yeah. So already WhatsApp group is created, and nearly 35 members added into the WhatsApp group. Whoever not clear the fee can make it by today. Okay. So everything will be shared in the group only. That is why make sure everyone can add into the group today itself. Okay. So today also same link we given. So maybe tomorrow the link will be changed. Okay, online guys. So tomorrow you cannot access. That is why. So everyone should add into the WhatsApp group today. Once you make the fee, you can forward a screenshot so that we'll add into WhatsApp group. Okay. Fine. So the course fee 11,000. This is offer price. Okay. Actually 22,000. This is a offer price. We are giving 11,000 only. Okay. You can grab this opportunity. So maybe next batch the pricing will not be available. This pricing will not be available. This may be changed. Okay. That is why you can grab this and you can add into WhatsApp group quickly. So in the group only we share all the information. Fine. Yeah. So tomorrow at same time 8 a.m. IST. So tomorrow we'll discuss about networking concepts, which are very very important. Don't miss the session. So types of networks: LAN, WAN, MAN, right? Different networks are there, and firewalls, load balancers, failovers, right? We'll go deep dive tomorrow. Fine.
So, do we get
Yeah.
any kind of notes and PPTs also?
The PPTs will not be shared. I'll give you documentation once start the AWS. Once start the AWS, I give you all the concept documentation, soft copy,
Okay.
PDFs. PDFs I can provide you.
Okay.
Okay. Yeah. Fine. So we can wind up here.